Today we are going to discuss about OSI model and TCP/IP protocol shoots. Introduction. We all know that before 1990s, the open system interconnection that OSI model would become the unlimited standard for data communication. But it does not happen. It was overcome by the TCP/IP protocol shoot, become the dominated commercial architecture that is widely tested extensively in the internet, where the OSI model was never fully implemented. Got it? Protocol layers. We all know that the word protocol stands for a set of rules. Here, this protocol is required when two entities need to communicate. When the communication is not simple, we need to divide it into a complex task into several layers. For example, Maria and Anna having a face-to-face neighbor conversation with a lot of common ideas. Protocol layers. Here we are showing that Anna has to move to the another city because for their job. Here in different layers he is using the different layers of protocol rules for the communication purposes. This is that for layer 1 for post offices, and in layer 2 for transistors, that is a security code purpose, and in layer 3 and Maria and Anna, that is Maria having a Spanish language that can be converted into an English language for understandable by the Annas. So these are all some of the uses of the protocol, that is for communication purpose. Protocol architecture, that is, and each layer says, that is, first one is a physical medium, then layer 1, layer 2, layer 3, layer 4 and layer 5. Each layer will having then interfaces. Here the word interface defines which is a primitive operation and services that lower layer makes available for the upper one. That is, the lower layer will provide some uses for the upper layer. This will reduce the complexity designs because the stack of layers or levels each built upon the one below it. The purpose of the layering is to service the higher layer with shielding those layers from the details. One important thing is no data is directly transferred from layer N to another layer. Got it? The first one is the OSI model, that is the Open System Interconnection. It is based upon the protocol developed by the ISO, that is International Standard Organization, as a first step towards an international standard purpose used for the various layers. The model is developed by them as Open System Interconnections, connecting the open systems. Got it? It was introduced in the year of 1970s. An open system is a set of protocols that allow any two different systems to communicate regardlessly of their underlying their architecture. Note, ISO is an organization, OSI is a model. Got it? The main purpose of the OSI model is to show how to facilitate the communication between the different systems without requiring changes to the logicals of their underlying hardware and software. This OSI model is not a protocol. It is a model for understanding and designing the network architecture that is very flexible and robust and interoperable. Got it? This OSI model is a layered framework for designing of network system that allows the communication between all type of computer system. Main thing is it is used for communication purpose and it is not a protocol. Okay. The OSI model consists of 7 separate layers, but they are related among each other, but each one having the different process of processing of moving the information across the network. The first layer is a physical layer, and second one is a data link layer, third one is the network layer, and the fourth one is the transport layer, fifth one is a session layer, sixth one is the presentation layer, seventh one is an application layer. The first 3 layers are the network support layers, and the next one, that is a layer 4, is only a link the 2 subgroups. Okay, and the purpose of last 3, that is 5, 6, 7, that is session, presentation and application listen, is an user supports layers. Okay, so these are all the 7 layers. Here one of the layered architecture simple example. For example, if the layer X want to communicate the logical communication between the layer X on the another machine. For example, a message is traveled from A to B. That is, this intermediate nodes usually involves only the first 3 layers of the OSI model. That is, for example, if the layer 3, consider layer 3 as an example, it uses the services provided by the layer 2. And that layer 3 can provide the services for layer 4. Got it? This is the single machine. In the layered architecture, interface between the layers means each layer defines what information and services the layer must be provided for the other layer above it. That is the process of the interfaces. But the upper OSI layer is almost implemented in software. The lower layers are the combination of hardware and software, except the physical layer, which is mostly an hardware. So the upper layers are most of the softwares, but the lower layer is combination of hardware and software, but the physical layer is only by the hardware. Got it? Here we have to know what is encapsulation. That is, packets at layer 7 is encapsulated in the packets at layer 6. The whole packet at the layer 6 is encapsulated in the packet at layer 5, as so on. That is, the process is starting at the layer 7. Okay, then it moves from a layer to layer in a descending sequence. That is, from layer 6 to layer 5, layers 5 to layer 4, towards it. Okay, at that, for example, at each layer the header can be added to the data unit. Got it? When they reach the layer 2, the trial may also be added. When the data is formatted, unit passed through the physical link. It changes into the electromagnetic signal and transported. First layer, that is the physical layer. We all know that physical layer is mostly by the hardware. Its coordinates are functions required to carry in the bit streams over the physical medium, and it deals with the mechanical and the electrical specification of interfaces and transmission mediums. It also defines the procedure and the functions that physical device and the interface has to perform for transmission to occur. The simple thing is, the physical layer is responsible for moving the individual bits from one node to the next node. Got it? That is, it is responsible moving the individual bit streams from one node to the next node. Some of the basic characteristics functions of a physical layers are, the characteristics depends upon this. It also defines the type of transmission medium they are used, and the bits here are represented in the form of single signals, that is electrical or an optical signals, that is a type of encoding in the form of zeros and ones, and the data rate can be transmitted in the bit streams in each seconds. Okay, synchronization of bits, that is sender and receivers or synchronized. Got it? The line configuration is point to point or either multi-point. The topologies used in the physical layers are mesh, bus, star and ring topologies. Transmission type of modem is simple, half duplex and full duplex. These are all the some of the basic characteristics of the physical layer. Data link layer. Data link layer transfers the physical layers of raw transmission facility to the reliable link. It makes the physical layer appears error-free to the upper layer of network layer. Framing. The data link layer divides the stream of bits received from the network layer into a manageable data units called frames. Physical addressing. If the frames can be distributed into a different systems on the network, the data link layer adds the header to the frame to define the sender or the receiver of the frame. That is, if the frame is intended of a system outside of the sender network, the receiver addresses is the addresses of the connection device to the connected device to the network of next one. So they are adding the sender and receiver data frames, that is header. The link layer of physical control. The flow of control process. If the rate at which the data is observed by the receiver is less than the rate produced at the sender, the data link layer processes the flow of control mechanism, that is to prevent the overleaving of receiving. Next one is the error control. Here the data link layer adds the reliability to the physical layer by additioning the mechanism to detect and retransmit the damages or losses of the frame. It is also uses a mechanism to recognize the duplication of the frame through by trial added to the end of the frame. Access control. That is, for example, when two or more devices is connected in the same link, the data link layer protocol is necessary to determine which device has the control over the given time. Next one is the network layer. This network layer is responsible for the source and destination delivery of the packets across the possibility of the multiple network layers. That is, for example, if two systems are connected to the same link, there is no need of for a network layer. However, the two systems are attached in the different network links. With the connection between the network links, there is often a need of the network layer to accompany the source and destination deliveries. Got it? This is the process of the network layer, that is to responsible for source and destination delivery of the packets between the multiple layers of same link or at the different network link. Logical addressing, that is the physical addresses implemented by the data link layer handles the addressing problems locally. That is, if a packet passes the network boundaries, we need another addressing system to help to the distinguishing the source and destination system. That is, the network layer adds a header to the packets coming from the upper layer among the other layer and includes the logical addressing of sender and receiver. Routing process. When the independent networks or the links are connected together to create a internetwork, that is network of network or a large network, the connection device is called router, which is used or switched to packets their final destination. That is, it is used to reach the packets to their final destination. One of the function of the network layer is provided their mechanism, that is routing mechanism is provided at the network layer to reach the packets or to the final destination port. Transport layer. Here the messages is divided into a transmittable segments, that is with each segments can containing the sequence of numbers. These numbers enable the transport layer to reassemble the message correctly upon the destination and to identify and replace the packets with the lost in the transmission. Connection controlling, it can be either connectionless or connection oriented, the transport layer. The flow of control is similar to that of the data link layer. It performs end to end rather than a single link. And the error control is also similar like a data link layer. The transport layer is responsible for error control. It performed to process rather than single link. That is, error correction is usually achieved through the retransmission mode by sequencing the segments of information. Got it? Session layer. This session layer is a network dialog controlled layer, that is it is used for establishing, maintain and synchronize the interconnection between the communication system. First we will see what is the dialog control. In the session layer, it allows the two system to enter into a dialogue, that is communication between the two process to takes place either in a half duplex or a full duplex mode. We will check by the synchronization method. Here it will process to add the checkpoint, that is synchronization point into a stream of data. For example, if you are transferring the data from the of 2000 pages, first it will add the checkpoint for every 100 pages to ensure the 100 page unit is received and get the acknowledgement independently. Suppose if there is a crash or there's any stuck between the page number 523, means this will send only the data after from 501. Got it? Presentation layer. This presentation layer is concerned with the syntax and the semantics information exchange between the system. Translations. First, the presentation layer is responsible for the interoperability between the different encoding method. Here, the sender changes the information from its sender dependent format into a common format. In this presentation layer, at the receiver end, will changes the common information format into a receiver dependent format. That is, encryption and compression processes takes place in the presentation layer. Finally, the seventh layer of OSI model, application layer. This application layer enables the user, whether it can be either a human or a software, to access the network. It provides the user interfaces and support for services such as electronic mails, remote file access, or transferring or sharing the data sets and other type of distributed information services. This application layer, it can be either a human or a software connection interface layer. Got it? The final summary of a OSI model is the physical layer will have the data in the format of bit streams over the medium and provide the mechanical and electronic specification. In the data link layer, the bits are transferred into the frames that provides the hops to hops deliveries. After to the network layer, the frames can be transferred into the packets in the form of packets from source to destination to provide the internetworking. At the transport layer, it provides the reliable process to process message delivery without error without error, that is error recovering. In the session layer, they establish, manage and terminate the session. Finally, at the presentation layer, they can encrypt, that is encrypt and translate and compress the data, that is by the sender understanding and to the receiver understanding. Finally, at the application layer, it allows to access the network resources. Please share my channel, subscribe my channel for more updates related to PGTRB exams. Thank you.